Well, I hope you're ready to tackle some of the biggest bears you've ever tackled today. We're going to try to put it all together. We've been building up to this moment as we've been investigating different characteristics and different aspects of rational functions, whether it was their asymptotes or their intercepts or the domain and range and sorts. We're going to put it all together today. I could almost guarantee there's going to be parts of today that are a little overwhelming, but we're just going to tap the brakes, take a deep breath, and kind of just reflect on things we've done over the past 4 lessons to get to this point whenever we get stuck. So our goal is by the end of the video today, we're going to be able to take this really wild looking function right here, and we're going to try to graph that function, come up with a really accurate, neatly well done graph without using our calculator. How scary is that? And it really comes back to being able to identify all the asymptotes and all the intercepts, and then a couple other tricks after that. So let's dive right in. Here's the summary. Here's the game plan for putting it all together. We're going to start off by finding the y-intercept, and then we're going to find the x-intercept. Then we're going to find the vertical asymptotes, if there are any. We're going to see if there's any horizontal asymptotes. And then that fifth step is going to be, that's kind of the wild card. You know, there are going to be times where you don't really need to do step 5, and then there's going to be other times where we have to put a lot of work into step 5 to get enough information to really nail the graph. Okay, so that's going to be our wild card. It's going to vary from problem to problem. All right, so right out of the gates, let's look at the rational function, the fractional function, 2x divided by the quantity x minus 1. And we'll try to have to go through these too fast here. So if you want to find the y-intercept, oh my gosh, I don't know if you can hear everybody screaming outside, but they're all bouncing around on the trampoline here, and hopefully it's not too distracting here. But for our y-intercept, I'm going to substitute a 0 for x, and we could say y equals 2 times 0 all over 0 minus 1, which makes, we'll say, I'll use a little arrow, y equals 0. So not the most exciting outcome we've ever had, but we'll take it. To find the x-intercepts, this time we're going to substitute a 0 for y. We know that by the time we cross multiply, it'll just be 0 equals 2x, which implies that x also equals 0. So in other words, this graph is going to go right through the origin if both your x and your y-intercepts are 0. Now, what comes next? Let's talk about vertical asymptotes. If you remember the process here, we want to make sure that the numerator and the denominator are already factored. We're going to make sure that there are no common factors. In other words, there's no holes. And then just identify the zeros of your denominator, which in this case is going to be x equals 1. For our horizontal asymptotes, we'll do a little review. We're going to perform what's called a power fight. We're going to compare the degree of the numerator to the degree of the denominator. Now, in this particular case, looking at the biggest exponent, we've got x to the first, x to the first. So that's same over same. And when you have same over same, you take the coefficients. Now, my coefficients happen to be 2 and 1. Let me highlight those. So I got a coefficient of 2. I got a coefficient of 1. So y equals 2 divided by 1 is the horizontal asymptote. So same over same. That's what you want to remember. Power fight, same over same, y equals 2. So let's see, what do we have right now? If I didn't do any other work and I only did the first 4 steps, what is this going to look like? All right. So we know that we've got to cross the x-axis at 0, cross the y-axis at 0. That puts me right there. I know that there's going to be a vertical asymptote at 1. Oh, dear. Let's see if I can get real brave. I'm going to try something here. Okay, so I drew in those asymptotes at x equals 1 and y equals 2. And like I said, sometimes you're going to get to this point and you're going to feel like you've got enough information to go ahead and draw what you got to draw. For me, I don't feel super confident. I don't feel like I've got enough information. And if we go back and we read step 5, let's go back and look at step 5 and see if we can make sense of it. We're going to plot points that are between and beyond. Beyond means to the right, to the left of each x-intercept and in vertical asymptote. So what they're trying to say there with that one is we say, okay, I want to find, something to the left of my x-intercept. I want to find something in between that x-intercept and the vertical asymptote, and then something to the right of that vertical asymptote. So what I'm going to do with my table of values here, and again, and I guess I should have said that earlier. In essence, that's what we need to do is we need to make a table of values. And that's really why we practiced it the way we did last week. All right. And again, what's really nice about this table is there's no limit to how many points that I could plug in my table of values. The less confident you are, the more points you want to pick, okay? You can never go wrong with picking more other than the fact that it takes more time and energy. So I'm going to pick something to the left of my x-intercept. I'm going to pick something in between the x-intercept and the vertical asymptote. And then I'm going to pick something to the right of that vertical asymptote. So those are the three x values that I'm going to plug in. When I substitute a -1 for x, I get -2 divided by -2, which makes 1. All right. When I substitute a 1/2, I get 1 divided by a -1/2, which makes -2. And when I substitute a 2, I get 4 divided by 1, which makes 4. So I'm going to go ahead and plot those points in addition to what I already had. So let's see. -1, 1, 1/2, comma, -2, and then 2, comma, 4. And what that does, and I guess with more, and you may be looking at this saying like, wait a minute, I'm not very confident what this graph should look like. Well, again, just plug in more points for x. Keep substituting until you feel confident. And with enough experience, you'll say, okay, I know it's got to start really close to this asymptote and then merge into this asymptote. Think about merging, when you're trying to get on the throughway and you're coming on that on-ramp, you're merging closer to that lane. Same thing here, we're merging. Just try to be as careful as you can that you do not touch those asymptotes. And hopefully our graph looks something like that. Let's go take a look at another example. So again, let's see if we can find all of the intercepts. So I'm going to start with my y-intercept. I'm going to substitute a 0 for x. And 0 divided by -4 makes 0. Notice we're going just a tick faster now. For the x-intercept, substitute a 0 for y. Cross multiply. And we'll get x equals 0. So we got y equals 0. We got x equals 0. For the vertical asymptote, we're going to factor it. Make sure there's no cancellations. Find the zeros of that denominator. So we got 2 vertical asymptotes, one at x equals -2, one at x equals +2. For the horizontal asymptote, we're going to do a power fight. Looks like second degree numerator, second degree denominator. Same over same says we're going to take the ratio of the coefficients and get y equals 3. So let's see if we can plot all of that information. Again, we're going to go right through the origin. Whoopsie daisy. Got to hit this button here. All right, there is my x equals 0, my y equals 0. We've got 2 vertical asymptotes and a horizontal. So what I did, I've drawn all my asymptotes, and again, I'm not feeling super confident about what this picture is going to look like. So I need to construct a table of values, and I'm going to talk about strategically picking which values of x you want to substitute. Again, I want to pick something to the left of that first asymptote, so I'm going to let x equal -3. Then I want to pick something between the asymptote and the x-intercept, so that would be -1. Pick something between the x-intercept and the next asymptote, which would be +1. And then lastly, I want to pick something to the right of the second vertical asymptote, and I'm going to go x equals 3. But, if you had picked, -4 instead of my -3, or you picked +5 instead of my +3, those are totally going to work. Like, it's not a really hard and fast rule as to which ones you pick. And I'm going to plug these back into f of x. Now, we do have a little bit of number crunching here. So if I plug -3 into this function here, I'm going to get a 27, and then 9 minus 4 makes 5. So that's going to be about 5.4, I think. Substituting a -1 makes 3, and 1 minus 4 makes -3, so that's going to be -1. Substituting a positive 1, I think, gives me 3 over negative 3, which is negative 1 again. Interesting. Substituting a positive 3 looks like 27 over 5, which again is going to be 5.4. So I'm going to go ahead and plot those. And really what you're trying to do with that table of values a lot of times is you're conscientious of whether that section of the graph is above or below the horizontal asymptote. That's a lot of times what you're trying to do. So in this case, negative 3 is going to be 5.4. That's going to put me in this neighborhood here. Negative 1, negative 1, 1, negative 1, and then again 3, comma 5.4. So what you know is that this section is above the horizontal asymptote. This next section is below. And then this next section, whoops, yeah, boy, it is hard to draw on this screen, I think. Okay, so that's roughly what this graph is going to look like. Again, it's always got to trend towards or merge into without intersecting all of those asymptotes. And again, with the more practice we get, the more confident you're going to get. I got one more real crazy. This is going to be a very challenging example, I think. Again, we'll probably pick up the speed just a little bit. For the y-intercepts, we'll let x equals 0, and that's going to give me y equals negative 4 over 0. In other words, it does not exist. There are none. There are no y-intercepts. For the x-intercept, we're going to let y be 0, cross multiply. And I think you may recognize this example from yesterday. We're going to go 3x. I believe we're going to go minus 4 and then x plus 1. Let me double check that in my head. Yeah, I think that works. So we're going to get x equals 4/3, which is about 1.3 repeating, and x equals negative 1. So keep track of those bears. For our vertical asymptote, we're going to factor the denominator. And so we're going to get x, quantity x plus 4. Now you'll notice nothing in that denominator cancels with anything that was in the numerator, so there's no holes. And we're going to have a vertical asymptote at 0 and at negative 4. So I've got 2 x-intercepts, I've got 2 vertical asymptotes, and then for the horizontal asymptotes, we're going to do a power fight. Looks like same over same, second degree over second degree, so y equals 3. I'm going to go ahead and hit the pause button and try to draw in all of my asymptotes here. So here's what I've got so far. I've got 2 vertical asymptotes, I got a horizontal asymptote, and then I also did the x-intercepts at x equals negative 1 and at x equals 4/3, or that 1.3 repeating. So now I'm going to make a table of values, and this is going to be the most challenging one yet, of course. I want to pick any number to the left of that vertical asymptote. I want to pick a number in between the vertical asymptote and the x-intercept. This one's going to be real tricky. There's a very tight interval here. I want to pick something like x equals negative 1/2 because I got to pick a number in between that x-intercept and the vertical asymptote. Then I got to pick one here, and then I got to pick another number over here. So let's say, for argument's sake, I pick a negative 5 here, maybe a negative 2 here, negative 1/2, positive 1, and maybe positive 2 for that interval. And let's see what that table of values is going to look like. All right, now this is going to be the most challenging table of values you may have ever made. But believe it or not, I think sometimes we just lack the confidence or that determination. And I know you've got the talent and the ability to do so. It's just a matter of kind of sticking your heels in the ground and making it happen. So when I substitute a negative 5 up here, okay, I'm getting 75 minus negative 5. So that's 80. 80 minus 4 is 76. On the bottom, I'm getting 25 minus 20, which is 5. And that turns out to be about 15.2. Now, again, the key is you're trying to figure out, is that point above or below the horizontal asymptote? So we're going to be well above that asymptote. Substituting a negative 2 is going to give me 12 plus 2 minus 4. That's going to be 10. 4 minus 8 is negative 4. So that's going to be negative 2.5. That point's going to be below the horizontal asymptote. Now this one's really nasty, and I'm just going to peek at my notes. I got about 11 over 28. And so we're going to say that's approximately, it's a little less than 1/2. For the sake of graphing, the key is it's positive. That's what you really want to focus on. Is this number's positive? It's going to be just a whisker above the x-axis. Substituting a 1 for x, it looks like it's going to be 3 minus 1 minus 4 is -2. On the bottom, we get 1 plus 4 is 5. That's a -0.4, so that's going to be below the x-axis or the asymptote. Substituting a 2 is going to make 12 minus 2 minus 4 is 6. 4 plus 8 is 12. Hey, that's 1/2. That's just a smidge above. So let's see how that translates here to the graph. See if we can put the finishing touch. Now remember, at -5, we had 15 point something. So we're way up here above. So that tells me we're going to live in this area right here. And I totally missed that point. Let's pretend that point's over here. Okay, the next one. At -2, we got -2.5. And then at -1/2, we got just a little above. So this graph is going to come up, it's going to swerve, and then continue. Now remember, we can crash through horizontals. It's going to continue. Now, how did you know it doesn't turn, Hill? Well, there was no other x-intercepts between, prior to that vertical asymptote, so I knew it was just going to keep climbing up. Let's see. At 1, we got -0.4, and at 2, we got 1/2. So this graph is going to do this. Zoop, 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 zoop. And again, just more practice, more practice, more practice. And that fifth step's a wild card. We just got to put our hard hats on and grind through it. But at the end of the day, you've got something really impressive to show for it. So great job hanging in there this week. 1 week at a time, 1 day at a time. We're solving one math problem at a time. See you guys.